the eye that studies beginnings. The witness that reaches all the way back to the first dawn. This is the James Webb Space Telescope. Not a machine. Not a mere collection of mirrors and wires. But humanity's most sensitive vision, an eye bold enough to face the deepest dark and draw meaning from the faintest flicker of ancient light. Its golden panels do more than reflect the universe. They collect the oldest whispers of creation, echoes of stars that collapsed long before Earth existed, shadows of galaxies erased from the present, and the tired photons that have drifted across the silent oceans of space for billions upon billions of years. Every fragment of light that lands on Webb's instruments carries a memory older than continents, older than oceans, older than life itself. Each distant glimmer is not just a star. It is a message, a preserved moment from the universe's earliest chapters. Webb listens carefully, turning these fragile beams into a cosmic melody, songs of vanished suns, quiet planets, and forgotten worlds. With each spectrum it studies, with each mystery it untangles, Webb becomes more than a telescope. It becomes a storyteller, a poet writing with rays of light instead of ink, translating silence into understanding. Its mission, written in engineering manuals and scientific diagrams, unfolds in space like poetry in motion, to expose the hidden chemistry of distant planets, to reconstruct the lost history of galaxies, and to help us recognize our place in the vast architecture of the cosmos. Recently, Webb turned its golden sight toward a calm, gentle star glowing softly 120 light-years from Earth, a lonely lantern suspended in the dark. No one imagined what would come next. For the first time, unmistakable traces of carbon-based molecules, the same elemental ingredients that support life on Earth, were revealed drifting in the atmosphere of a distant exoplanet. That world is K218b, a planet unlike anything in our solar system, yet familiar in its promise. About 8.5 times Earth's mass, it circles its star within the warm, golden band where liquid water could exist. Webb detected a hydrogen-rich atmosphere laced with methane and carbon dioxide, a chemical mix that hints at oceans hidden below. Could this celestial world be wrapped in global seas? Could life, in some alien form, be waiting beneath those clouds? Long before Webb, Hubble offered gentle hints, signs of vapor, a hydrogen blanket. But Webb pushed deeper, sifting through the filtered starlight with unmatched precision. Among the molecular fingerprints, patterns of complex carbon chemistry appeared. Even more remarkable, no ammonia, suggesting a stable, balanced environment. Then came the soft but startling signal, a possible trace of dimethyl sulfide, DMS, a molecule produced on Earth only by living organisms. If that signal holds true, it would mark one of the most profound discoveries in the history of science. For now, the data is faint, a whisper barely audible in the cosmic noise, yet the possibility alone opens a doorway humanity has dreamed of for thousands of years. Even with all the excitement surrounding K218b, scientists offer a quiet reminder: this world may be nothing like Earth. No blue skies. No familiar continents. No comforting landscapes. Instead, it could be something far stranger, a hybrid world that defies our expectations. Part mini Neptune, wrapped in thick gases, part ocean planet, hiding an endless sea beneath its swirling clouds. Imagine such a realm. A world bathed in gentle, dusky starlight, the kind that paints everything with a soft golden hue. Below, an ocean so vast it never sees land, its surface stretching into infinity, a dark mirror reflecting the distant light of a cool red star. The clouds above glow faintly blue and violet, their colors shifting as hydrogen mist drifts through the atmosphere. There are no mountains to break the horizon, no islands, no coastlines, only an eternal water world holding secrets deeper than any ocean on Earth. Each time this distant planet glides across the face of its star, A thin blade of starlight cuts through its atmosphere. That sliver of light picks up faint chemical traces, a subtle, shimmering fingerprint of everything hidden within its cloudy veil. Webb captures those photons with exquisite precision, decoding the information they carry. Patterns become wavelengths, wavelengths become chemistry, and chemistry becomes understanding. Through that pale glow, K218b slowly takes shape in the human imagination, not as a cold, distant number in a catalogue, but as a living world painted through science, patience, and the delicate language of starlight. Soon, Webb will examine this world again using its MIRI instrument. Each observation will peel away another layer, searching for drifting clouds, circling storms, perhaps even the rhythmic cycle of carbon that echoes the very processes life uses on Earth. And yet, beneath all of this research lies a question older than maps, older than civilization itself. Are we alone? To answer it, Webb looks not only to the nearby exoplanets of our cosmic neighborhood but also to the earliest pages of the universe's story. In a distant galaxy known as SPTO 41847, Webb uncovered the faint signatures of complex organic molecules, the very carbon-rich compounds found in smoke, oils, and even the cells of living organisms. What stunned scientists was not just the molecules themselves, but when they formed. These compounds existed when the universe was only 10% of its current age. The light Webb detected began its journey nearly 13 billion years ago, a time when galaxies were young, stars were newborn, and the universe had barely settled after the Big Bang. This single discovery overturned long-held assumptions. For decades, scientists believed such chemistry emerged only after multiple generations of stars lived and died, scattering the raw materials of life across the cosmos. But Webb revealed a universe that refused to wait. A universe impatient to create. A cosmos ready to assemble the ingredients of life almost as soon as physics allowed atoms to exist. These carbon signatures aren't scattered randomly. They gather in star-forming nurseries, places where new suns ignite while the building blocks of life swirl in the same neighborhoods. It is as if the birth of stars and the chemistry of life are woven together on the same cosmic loom. Despite its youth, this remote galaxy shines with heavy elements, carbon, oxygen, and the glittering seeds from which planets and possibly life itself may someday emerge. The message is undeniable. The universe did not waste time. Could life, simple, primitive, or otherwise, have begun far earlier than we ever dared imagine? Could the universe itself be structured, almost programmed, to generate life wherever conditions permit?